Ladies and gentlemen, I'm here. First, I'm very glad to have a presentation here. My presentation is about some loam exposure situation in China and also some loam residuals of waste management in China. This is the emerging issues in the past 5 or 6 years. In the past, in this area, just only managed by the EHS system or standard in norm. It's not including the radiation protection in this society. So that's new sections for radiation protection in China. How to? The first I have some briefly introduction. And the second is exposure level, and there is waste management. China is one of the countries with the most mineral resources in the world. And the mineral resources in China was divided into 4 categories. I think everybody knows about it. And according to the China Land and Resources Bulletins in 2007, 171 resources we discovered. About 159 kinds of minerals with proven of resources of proven reserves of resources, just as we show this paper, these figures, and this is a very famous tin miners in China. It's located in Yunnan province. About 1,000 years ago, some explorers have some workers in these mountain areas. And this slide shows some people or some employees involved in the loam industry or some activities in China. Now, there are more than 24 million peoples related to loam activities in China, and there are 10.5 million farmers for agricultural greenhouses. These activities just only occurred 5 or 10 years ago, so increased very fastly. So this, but at the parents, the individual dose is relatively low, but it's a big population in China concerning these activities. And also we have 7.8 million people, drivers of the road transportation. This is a specific issues in China compared with the airplane. Normally we have the driver, you driver, you are anywhere, you cannot account it. But compare by airplane, the road and the ship, by ship, just in China, there are many people located in Tianjin and Beijing, but every day he working in the Shanghai. So the high speed in China, so we can have high speed and by ship and by airplane every day. In the morning, start from his living city, and go back his home. So this because it's a large population, but for we count the calculation dose is very bigger. And this is other. It is one of the biggest population concerned loam exposure in China. At the general public concern. This some sites considered loam, just as Yunnan tin is very famous in China. About 100 years ago, we have found some paper. The Horner described this situation for the Yun-19 mineral exposure. The system of radiological protection in the 1990 recommendations is based on the practice and the intervention. But in the 2011 year's recommendation is 3 types of exposure situation. From this difference recommended from the ICRP, in China we have thinking about all the exposure should be kept on a radar. This law, I cannot understand what is the level. We can measure it. We can demonstrate it. We have a result, just only it's the mean of distribution. But everybody concerned is his individual exposure, individual dose. So for the final disposition of his work, they cannot, sometimes it's equal to the mean values, but sometimes bigger or sometimes smaller one. So the general public cannot, you should have told me it's compare the regulation or do not comply with the regulation or the limits. So this is a big issue in the practice in China. And we also have some discussion about the controllability and some situations. So in China, it's our biggest circumstances we discuss about this one. Another issue in China is about disposal options. Let's discuss it. The second is normal is about the normal exposure. We have a national project on this assessment of the dose normal exposure in China. So we have accepted the ICRP recommended methods to the measurement and the analysis and the dose assessment. And all of this is from the method is from the ICRP. So that's it's no any special cases. And here I will allow this for most of the coal miners radon concentration. We use a continual measurement more than 1 year. In the past, we just only a graph measurement, just only 1 week or 1 hour or 2 hours. So we have a very confidence about the radon concentration in the coal miners. This slide shows the exposure to the normal industry in China. This figure we can see more clear. In China, the radon exposure to the Chinese population, awaited Chinese population is 1.16 millisievert. Now, so most of some of the normal industry is bigger, is more than this average values of dose. Now, the most one is for the average dose is from the non-metallic minerals, and the second one is transportation. It's natural kiwi. In China, there are many natural kiwi. Somebody have visited to the kiwi. the most of the exposure is from the camera employee. He can, everybody working more than 12 or 60 hours per day. So his exposure, individual exposure is 3.1. And here we are mentioning is about the transportation is a minor dose. Just comparative to the air by airplane. Yeah, if you have another choice, so I have for the ground load transportation and high speed, you have a relatively low individual dose. That is a decreased values. And another I mentioned is about the coma. In the past, coma is 2.4 millisword per year, but since 2011, we have a national new policy on the control of coal miners' exposure. So the small one is cut. So and the other one is increase some protection measurement, just as increase the venting volumes of the air. So the dose is decreased. Now, that is a general introduction of the normal exposure. Here, lastly, we have some briefly introduce of the normal waste management in China. Now, this slide shows the residuals, solid residuals contain norm in China. There are more than 171 million tons residuals in China. It's mainly from the iron mines and the manganese coal mines and the copper mines. These are bigger volumes and it needs to, how to say, final disposal or storage. There's no answer in China. And this slide shows a difference of active concentration of each nuclide in China. Some of them is more than 1 becquerel per gram, and the other, some of them is near the 1 becquerel per gram, and some of them is, most of them is far below the 1 becquerel per gram. But for this situation, it's very difficult to control or to have, sorry, not control, have a final decision for each matter. You can have acceptance criteria in each cases to manage this situation. So we have some discussion for have a suggestion some difference numerical criteria such as 1 becquerel, 10 becquerel, and some other papers 100 becquerel should be used for control or manage of different kind of rad waste or normal residuals. So it's very difficult in China to have a unified one values to use it to different in different situations. And Sir Jeff briefly some discussion about what is waste, what is residuals, what is exempted waste, and what is the meaning and meaning of uranium waste. There's no answer. There's no finally answer or decision how to deal with it. If we consider taking account of the normal residuals, but the uranium residuals, it's very small of its value, but its active concentration is relatively high. So there's a difference that all from norm or nature nuclides. So in general, norm residuals may be very low level waste or low level waste. In China, we just have taken to these classes will be managed. And this slide show we have accounting with different activity concentration of these normal residuals. As there are about 80% of the residuals is its activity concentration more than 1 baker per gram. So that's a big portion of this activity concentrations. And there's about 5% just more than 10 per gram, 10 per baker per gram, and the rest is about the rest is about 26 million tons from 1 to 10 baker per gram. Just only the roughly estimation of the by statistical sampling. And for the safety management of these residuals, some have been unable to find or trace the responsible person. That's the Chinese cases. I cannot find the person. He disappeared. Yeah. This so how to deal with this situation is a special case in China. And also we have as another issue is that normal residuals are managed has the same requirements of the management of final disposal. For example, of uranium residuals or waste. The local government asked the government you should be do like this one. And there is no definitive conclusions in China. So we just, by the way here, by the way, we have some more information about the review of the IAEA GSR number part 3. And we also have how to accept the IAEA and the ICRP 103 publication into the new Chinese basic safety standards. So that's we in the process of discussion about this. Maybe some new publication of the ICRP will be taken account in the Chinese new BSS. So now we are just in the discussion about it. Here are just some remarks, just not the conclusion. The 3 points here. Based on the controllability of the loam exposure, many of the exposure to loam activities should be managed based on the radiation safety requirements in China. Yeah. The second one is based on the agreed approach. Most of the loam activities should be managed as for the waste should be managed as large waste in China, just maybe 5%. And how to implement the final disposal of loam residuals or waste is needed to be more discussions, taking into account economical or social actions in China. Here, for example, some people think the national standard or individual dose limits is for values monitoring. But for any person, you can find your located, your working place or living home, the monitoring result is more than 5% or 10%, 1% more than. I'm okay or not okay. So just we how to manage the limits or the reference level, and for the real results from the monitoring or the assessment. That's different ideas for the regular body, for the scientists, and for the local public. Thank you.
So we have time for a few questions. First one, there's you had a slide with a comment on the dose distribution ranging from 0.1 to 100 millisieverts in China.
Yeah.
What group's at the upper end, the 100 millisieverts?
Yeah. Here I like to focus on the distribution of the individual from the normal industry. In some specifics, in the place, the radon concentration is more than 10,000
becquerels per cubic meter.
So in most of them, it's not controlled or not managed. So for this area, the individual dose is very high. And we also have some generally, how to say, just this room. Sometimes the radon concentration is very high, but if before just this room, before the meeting, we have some measurements, such as increase the air. Yeah. So the concentration is lower. So the auditors ask the manager of this building, you should be told me at any time you comply with the national regulations.
Okay.
So that's a big difference. Yeah.
I had my own question related to the doses. You had a slide with the different job types, and you had range of doses. Is that part of a routine monitoring, or was that a special study that you did? How did you get that information?
Just
you had, like
for the figure,
rare earths were at 1.77, and non-ferrous metal mines were at 5.4 millisieverts. Was this routine monitoring, or is this
routine?
So
just a routine monitoring, routine working period. We have measurements, but another we have a continued measurement of the radon. Just only the working period. The radon just was for each day is 20 hours measurement of the radon, not on the routine working period.
Okay, so it was a special study to get this information?
Yeah.
Okay. And question now, switching to the waste side, how are NORM residues managed? Are they stored on site, put back in the mine? How are they being managed?
For the NORM industry, most of the situation is stored, located, and the location is where, how to say, is dispersing, is scattered, located the mining factor. So it's so huge, and its distributed is so scary. So it's hard how to connect it for how to say collectively disposed of it. So it's very difficult.
Mainly on site.
Yeah.
Okay. Any questions from the audience? Okay. Thank you.
Thank you.